Welcome back to reactions. This is part 2 of our unit, and specifically we're going to talk here about what is redox. In our previous video we talked about types of redox reactions, but not what made them redox reactions. So that's where we're starting today. First thing you need to know is oxidation numbers. Essentially that is the charge on the atom if it became an ion. To determine what's being reduced, the thing that's gaining electrons, or what's being oxidized, the thing that's losing electrons, because remember, redox has to do with the gain and loss of electrons, we need to look at the oxidation number. So here's the rules for oxidation numbers. Atoms in their elemental forms, including diatomic molecules, are always 0. So that would be plain lithium has a charge of 0, or plain iron has a charge of 0, or oxygen, the diatomic molecule, has a charge of 0. Hydrogen and alkali metals, those in group 1, are always +1, except when hydrogen is bonded to a metal, then hydrogen has an oxidation number of -1, but this is really rare. So if we had an alkali metal in a compound, not on its own, such as LiCl, that alkali metal will be Li+. If we had hydrogen in a compound, let's say HCl, that hydrogen would be plus. The exception, and again, this is really rare, not something you're going to need to see very often. If we had a hydride such as NaH, the Na is the positive one, so H has to be -1. Then our last rule, oxygen is always -2, except in peroxides like H2O2 when oxygen is -1, but again, this is really, really rare. This won't happen very often. So if I had something like MgO, O in a compound is going to have an oxidation number of -2. Or if I had Li2O, O in a compound is going to be -2. The exception, hydrogen peroxide, O is -1 and hydrogen is +1. But not something you're really going to need to know. It's really rare, but just want you to know that it does happen. One other thing that I left off the list is those transition metals that do not have varying oxidation numbers. Silver specifically will always be +1, zinc is +2, and aluminum is +3. The transition metals that do not have varying charges will always have those particular oxidation numbers. If a molecule when in a compound, not when it's on their own. If a molecule does not contain any of the above, the more electronegative element has an oxidation number that matches its group on the periodic table. These are some examples of how this works out. Here we've got determine the oxidation number for each element in the compound below. So if I have K, K is an alkali metal, it will always be +1. Then I have O, oxygen, will always be -2. But there's 3 of those -2s, so that's really a total of -6. And there's 1 potassium, that's +1. Notice the compound as a whole does not have a charge, so as a whole the compound is 0. So what does nitrogen have to be +1 minus 6 to equal 0? Well, +1 plus 5 minus 6 equals 0. And so nitrogen in this case is +5. +1 plus 5 and -2. That's the oxidation number of each individual element. If we have FeCl2, neither one of these is in the rules we just stated. So the one that is more electronegative, that's chlorine, gets its basic charge from the periodic table, and that's -1 because it's a halogen. Since there's 2 of them total, that's a total of -2, and the compound does not have a charge, so the compound overall will have nothing. So what does iron have to be -2 to equal 0? Hopefully you got +2. For Al2S3, aluminum does not have varying oxidation numbers. Aluminum will always be +3. And there are 2 of them, so that's a total of +6. The entire thing is going to be equal to 0, so what does sulfur have to be in order for it all to be equal to 0? Well, it's going to have to be -6. But there's 3 of these sulfurs, so each sulfur is not -6. Each sulfur's got to be -2. Now for the next 3, try these on your own. Pause the video here before you listen to me give the answers. Okay, but really, pause the video. Try them on your own. Alright, I'm going to trust you that you did it. Na2SO3. So, Na, gotta be +1 because it's a halogen. Oxygen, gotta be -2 because it's oxygen. So for sulfur, that's the tricky part. The entire compound, since it doesn't have a charge, all of their oxidation numbers add up to 0. For oxygen, since it's -2 and there's 3 of them, that's going to be -6. For sodium, since it's +1 and there's 2 of them, that's going to be +2. So what does sulfur have to be? +2 minus 6 to equal 0? Hopefully you said +4. +4 for sulfur. In the next one, the entire compound is going to be equal to 0. Oxygen is always -2, but since there's 2 of them, that's a total of -4. So sulfur minus 4 equals 0, got to be +4. And then in our last one, PbSO4, again, the entire compound is going to be equal to 0. Oxygen is always -2. But here's a trick. Lead and sulfur, neither one of them are always anything particular. Neither one of them come from our list of this is what the oxidation number has to be. So here I want you to recognize that sulfate is in this compound, and sulfate as a group has a -2 charge. So I'm actually going to look at that sulfate as a group to figure out sulfur, and then once I've got sulfur, then I'll look at lead from there. So for sulfate as a group, the entire thing is equal to -2. And oxygen within that group is -8. So sulfur minus 8 equals -2 has to be +6. So now that I know that sulfur is +6, based on what I know about sulfate and the polyatomic ions that I memorized earlier in the year, now I can figure out lead. The entire compound, again, has a charge of 0. Oxygen is -8. We've just decided that sulfur is +6. So what does lead have to be? +6 minus 8 to equal 0. Looks like it's going to have to be a +2. Let's try a couple more examples. So the difference between these examples is now that they're all polyatomic ions. They all have an overall charge. And sulfate is the first one. By luck, that's the one we just finished doing. Oxygen is going to be -2. This -2 here is not oxygen. It's just coincidental that that happens to be the charge for oxygen. This number is the charge for the entire compound. Oxygen, coincidentally, happens to also be -2. So that's a total of -8. So sulfur has to be +6. For the next one, the entire compound as a whole, oxidation numbers add up to -2. Oxygen is coincidentally also -2, but since there's 3 of them, that makes -6. So carbon has to be, what number minus 6 equals -2? Let's go with +4. And then permanganate, as a whole, this polyatomic ion, oxidation numbers add up to -1. Oxygen is also always -2, and there's 4 of them, so that's -8. So manganese, minus 8 equals -1, has to be +7. For the next 3, try them on your own. Pause the video now. Do it. Okay, hopefully you did. Let's look at nitrate. As a whole, the ion is a -1. Oxygen is always -2, but there's 3 of them, so that's a total of -6. So nitrogen, minus 6 equals -1, has to be +5. In the next one, it looks very similar, nitrite instead of nitrate. It is very similar. -2 for the oxygen, -1 for the whole compound. It's just that this time, since there's only 2 oxygens, they add up to a total of -4. So in this case, the nitrogen has an oxidation number of +3. And then in our last one, PO4 minus 3, the entire compound is, or ion, is -3. Oxygen is -2, and there's 4 of them. So phosphorus has to be +5. Hopefully you got all those right. So how do oxidation numbers help us determine what is redox? Well, the term oxidation means loss of electrons, or the oxidation number increases. And the term reduction means gain of electrons, or the oxidation number decreases. This oil rig is there to help you remember. Oxidation is loss of electrons. Reduction is gain of electrons, so oil rig. And the word redox comes from reduction Oxidation. Redox. Right there in the word. If you have oxidation, you must have reduction. If one thing is losing electrons, they have to be going somewhere, so something else has to be gaining electrons. So, to figure out what's redox, some reactions involve oxidation and reduction, others do not. To determine, use the oxidation numbers that you now know how to find. So in the reaction, C plus O2 makes CO2. Let's look at the oxidation numbers. Carbon by itself has an oxidation number of 0, because any atom by itself is 0. Same with oxygen. All by itself, it's 0. But within the compound carbon dioxide, oxygen is -2, and since there's 2 of them, hold on, the whole thing equals 0. Since there's 2 of them, carbon has to be +4. So we've got a +4 and a -2 is where the oxidation numbers went, even though they both started at 0. So we've got carbon starting at 0, carbon going to +4. The oxidation number has increased. Carbon has lost electrons. It is said to be oxidized. For oxygen, it went from 0 to -2, so the oxidation number got reduced, and the oxygen gained electrons. So in the reaction, 2NaCl makes 2Na plus Cl2. Let's look at how the oxidation numbers change. In the beginning, on the reactant side, Na is +1 and Cl is -1 because they're in a compound. But in the end, on the product side, they're both 0 because they're both plain elements. So we've got Na plus going to Na0. Look at the oxidation number. From a positive down to 0, the oxidation number went down. Na plus gained electrons and is being reduced. I can tell that it gained electrons because electrons are negative, which is why the oxidation number went down. For chlorine, since it started at a negative and went to 0, it actually went up. So chlorine must have lost electrons, and so we say that chlorine has been oxidized. Let's look at another couple examples. In the reaction Fe plus CuCl2, ooh, look here, it's single replacement. Iron by itself on the left is 0. Copper by itself, let me make a prettier 0. Copper by itself on the right is also 0. But within a compound, they have oxidation numbers. Chlorine is -1 because it's the most electronegative. Since there's 2 of them, copper has to be +2. And then we have chlorine is -1. Since there's 2 of them, iron also has to be +2. So we've got iron going to iron +2. Fe0 to Fe +2. Look at the charge. It went up. The reason why it went up must have been because it lost electrons, and so if it lost electrons, that's oxidation. For copper, it starts at +2 and it ends at 0, so the oxidation number is going down. It's going down because it gained electrons, and so it's reduced. Notice that chlorine did not change its oxidation number. It remained a -1 on the left and on the right. So chlorine is called a spectator ion. It's not involved in the reaction at all. Let's look at the next one. In the reaction, HCl plus NaOH makes NaCl plus HOH. Hydrogen is +1, because it always is. Chlorine is -1. Sodium is +1. Hydroxide, notice hydroxide as a group is -1. Sodium is +1, chlorine is -1, hydrogen is +1, hydroxide is -1. The charges didn't change. Hydrogen stayed +1 on both sides. Hydroxide stayed -1 on both sides. Sodium, chlorine, they stayed the same charge on both sides. So this is not a redox reaction. All ions kept their same oxidation number. So here's some more examples. We're just going to look at them and to determine if they're redox. Notice this A is the one we just looked at. Hydrogen is plus, Cl is minus. Sodium is plus, OH is minus. Sodium is plus, Cl is minus. Hydrogen is plus, and this is not oxygen, really. Hydrogen, hydroxide is water, OH is minus. This guy is not redox. For B, we've got Mg by itself is 0. Oxygen by itself is 0. In a compound, magnesium is +2 and oxygen is -2. So this one is redox. For part C, iron by itself is 0. In a compound, H is plus, Cl minus. In a compound, Cl is minus, and there's 2 of them, so iron's got to be plus 2. Hydrogen by itself is 0. This is redox. For the next one, Hg. Wait, actually, for the next one, you should be doing these. Pause the video now. Okay, I hope you did it. Alright, let's get started. In this next one, Hg is plus 2 in a compound because oxygen is minus 2 in a compound, but by itself, they're both 0, so this guy is definitely redox. Then we have AgI. Ag, remember, is always going to be plus 1, I minus. Nitrate as a group is minus 1, so lead has to be plus 2 in this case because there's 2 nitrates. Silver's always plus 1. Again, notice there's a nitrate there, which is minus 1. And then iodine is minus 1. It's the more electronegative of the 2, so I know that one automatically. There's 2 of them, so lead is plus 2. Check this out. Silver stayed plus on both sides. Iodine stayed minus on both sides. Lead stayed plus 2 on both sides. Nitrate stayed minus 1 on both sides. This guy is not redox. And for the last one, Mg is 0, plus, nitrate is minus. Mg is plus 2, nitrate's minus 1, hydrogen 0. This guy definitely is redox. Hopefully what you've noticed, redox reactions tend to have a single element on one side, either the reactants or the products, and then that element within a compound on the other side, so that the element will have to have changed oxidation numbers because by itself it's always 0, and in a compound it's never 0. So if you ever see a single element on one side, either reactants or products, and then that element in a compound on the other side, either reactants or products, that reaction has to involve losing and gaining electrons. So let's look at these half reactions and determine whether they're oxidation or reduction. So we've got copper going to copper plus 2, copper 0 going to copper plus 2. Notice the oxidation number is getting bigger. Since the number is getting bigger, that must mean that it's losing electrons, and oxidation is the loss of electrons. Now, those electrons actually should appear in the reaction itself. So since it's losing electrons, the electrons themselves should be products, like given off. So we're actually going to add E negative into the reaction, and 2 of them in this case, so that I end up having charges that balance on both sides. We've got a 0 total on the left, and plus 2 and minus 2 is a 0 total on the right. For the next one, chlorine 0 on the right turns into chlorine minus. Notice the oxidation number is getting smaller from 0 to minus. That must be because it gained electrons, or it's undergoing reduction. Now, gained electrons, that means the reactant had to take in those electrons, so the electrons are actually on the reactant's side. Now, if you're going to balance this reaction, notice 2 chlorines, so I have to have 2 chlorines, which is 2 minuses on the right-hand side, so I'll need 2 minuses on the left-hand side to get the reaction to balance. Both sides of the reaction don't have to equal 0, they just have to equal each other. So in this reaction, I've got 2 negative on the left, 2 negative on the right. It is a balanced equation. And then for my last one, I've got chromium plus 3 turning into chromium 0. Notice the charge is getting smaller. Since the charge is getting smaller, it must be because it gained electrons, and reduction is the gain of electrons. And so, gained electrons means the electrons has to be on the reactant side. And in this case, 3 of them, because there's a 3 plus. So that the total charge on the left is 0, and the total charge on the right is 0. So what you need to take away, oxidation and reduction. Oxidation is the loss of electrons. Reduction is the gain of electrons. That's your biggest thing you need to remember. Oxidation is the loss of electrons. Reduction is the gain of electrons. Just chant it over and over and over again until into your head until you've got it. All right, we'll see you next time.